Hello students, welcome to our AriserTalent. Student, I am your maths faculty Arpita Sharma. We were discussing this chapter circle in our previous lecture and we have gone through some theorems, a few theorems actually, and now we have arrived to this one. Two tangents TP and TQ are drawn to a circle with center O. The center from an external point T. This is the external point T, students. Prove that angle PTQ is twice the angle OPQ. Okay, students. So, let me tell you what this question is telling you. This is telling you this is a circle. Okay. Now, this circle with the center O. Okay. Now, we are having a point outside it here and we'll name it T, and we are having two tangents from here. One is TP and another one is TQ. Okay, students. So, this is O, this is P, this is Q and this is T. Now, it's saying that it will subtend an angle here. Okay, and there will be also an angle. When you join this PO and we'll have this chord PQ, then this angle made by this chord and the radius will be what? Half of the angle made with the two tangents, right, from the outside point. So, you have to prove this. Okay. Alright. So, we will now be discussing about this. Okay. So, to prove, what we have to prove? That angle OPQ is equals to twice, that is not okay, this angle, right. So, what I will say that this angle PTQ is equals to twice of this angle OPQ. Now, this what I have to prove, and what I am given, what I have provided with, I have provided with this circle having center O and from an outside point, which is what? T. I am having PT and QT are two tangents angle PTQ equals to theta. Okay. Let's suppose that this angle is equals to what? Theta. I am assuming this. Okay. Now, this angle is theta. Now, I have to know about this. So, what will I do? What can I do is, okay, I can have this by construction and this by construction. Okay. So, can I meet TO and OQ? So, here is a construction. Construction is what? Meet O to T and O to Q, right. Now, if I go to this triangle and this triangle, so I will talk about this like this angle will be what? Theta by 2 and this angle will be what? Theta by 2, right. Now, if this point is, let's suppose, R. Okay. So, if this point R, why it's theta by 2 and theta by 2? You have remembered that if you are having a point there, right there, outside the circle, and you are having two tangents, then these two tangents TP and TQ will be equal, plus second, this angle will be bisected by this line, okay, which is coming from radius to that outside point. So this is the bisector, this is the angle bisector of this, and this is also bisector of line PQ. So here, by this we can say that, I am starting our proof, right. I am saying I am saying that angle PTO equals to angle OTQ equals to what? Theta by 2. If I am having this angle theta, okay, so I can have this here as theta, so this will be theta by 2. Why? Because TO is angle bisector, right? So is that true? Okay, so these two angles are equal. Which one? This one and this one. Now what I am having? I am having this angle theta by 2 and this angle theta by 2. Now if I look in this triangle, in this particular triangle, this angle and this angle are what? Equal. Why? I am saying angle TPR equals to angle TQR. Why? Because this TQ equals to TP, TQ equals to TP, and why it is so? They are tangents, and tangents from the same point are basically equal. So I have concluded with this angle is equals to this angle. Now this angle is theta and these two angles are some angle. So what will be the sum of these angles? This angle P is equals to this angle Q. So I can write in triangle PTQ implies angle P plus angle T plus angle Q equals to what? 180 degree. The sum of these will be what? 180 degree. Okay. So what I will write now? What I am having? This angle T is equals to theta. So I will be having theta plus angle P plus angle Q equals to 180 degree. Now angle P equals to angle. Now angle P is equals to angle Q. Let's mark this equation 1. From equation 1, what we are having? Angle P equals to angle T, angle P equals to angle Q. Okay. So this implies that 2, now I am considering this and this, 2 angle P, right, plus theta equals to 180 degree. What it gives you? Theta will be equals to, or you can say angle P will be equals to, angle P will be equals to 90 minus theta by 2. How? Because we'll take this theta here, so it will be 180 by 180 minus theta, and we'll divide it by 2. So 180 divided by 2 will be 90, and theta by 2 will remain theta by 2. Okay. So this is our second parameter. Now what I get? I get this angle as 90 minus theta by 2, or I can write it like this so that you cannot be confused. Here this angle is calculated as 90 minus theta by 2. Now these both angles are similar. So this is also 90 minus theta by 2. But I am more concerned with this. I am more concerned with this because I have to take the relationship of this with this angle. So now I am clearing it till here. Okay, right from here. Okay, students. So now what will I have? I'll simply have now angle OPT equals to what? 90 degree, right? Why? Because this OT, this PT is perpendicular to this OP. Okay, this is the tangent and this is the radius. So radius will be always perpendicular to tangent. We have proven that in our last session. Okay, so now this will equals to OPT. This is equals to what? Angle TPQ plus QPO that is equals to 90 degree. Now I am having the value of this TPQ. Okay, this is what? This is the same angle P here. So TPQ is equals to what? This is equals to what? 90 minus theta by 2. Okay, and the same angle, right? I am rubbing the remaining part too. Okay, students. So by this angle QPO, this is the angle QPO that I have to find. Okay, now I will be finding it in the terms of this. So I can write it angle QPO equals to what? This will cancel out, theta by 2. Now what is theta? Theta is our angle. We have assumed this as angle theta, that is PTQ. So angle PTQ by 2. So what will it give you? Angle PTQ equals to 2 angle QPO. Okay, so what we have to prove? That angle PTQ equals to angle QPO or OPQ, hence proved. Okay, students, note this, right? Now, moving to the next one, we are having PQ is a chord. This PQ is a chord of length 8 centimeter. This is of length, I am telling you, this is of length 8 centimeter, that is given in question. Now, of radius of circle 5. So, this is a radius, so it will be 5 centimeter. Okay. Now, the tangents at P and Q, this P and Q point intersect at a point T. So, I am having these tangents, okay, and they are intersecting at a point, and this point is what? T. Okay, so I am having this point T here. Okay, so T is here, P is here, Q is here and O is here. Now it is saying find the length TP. Now I have to find this length. Now you can easily say that ma'am, this is our right angle triangle. Okay, because this is our radius and this is our what? Tangent. So tangent and radius will give us a 90 degree angle. Now I am having this 5. Okay, Now I am having this 8. I have to find this. So how will I found this? I can find it if I am having this side and this side or this side. So that in that way I can find it. Now I am having this as 8. So if this is 8, this PQ is 8. So it is what? Angle bisector of this angle and also the bisector of this PQ chord. Now if it is a bisector, then it will be of what? It will be of 4 centimeters and it will be of 5 centimeters. So if I am taking this out from this construction, I will be having this kind of triangle P, O and T. This is 90 degree and I am having this. Okay, now this is equals to 4, right? This is equals to 5. Okay, this is equals to 5. Now I have to find this one, right? Okay, so let's find TP. I'm having a name for it, like make it S. Okay, make it S. Okay, so now here I'm having this length equals to this length, right? Or what else I can do? I can just simply find this and this. I can find this, right? So okay, in this triangle in triangle POS, what I'm having, because this is right angle triangle, okay, so summation of this and this will give this, okay. So 5 square will be what? 4 square plus x square. So x square can be known as 25 minus 16, that is equals to 9. So x equals to what? 3. So this length is 3. Okay. Now this length is 3. I have to take out this form, and what else I am having? These two are similar. Okay. So, okay students, so we will now be taking these two triangles in triangle first PTS and the second triangle PSO. What we will find that this PS is common. So, PS equals to PS, that is common side. This is one. Now, angle TSP equals to angle PSO equals to 90 degree. This is second. Now, if we talk about this angle and this angle, these will be equal. Why? Because angle, this is 90 degree, the summation will be of this T angle and this P angle will be equals to what? 90 degree. So, angle PTS plus angle this TPS equals to 90 degree. Okay. And again this angle, right, this particular TPS, right, TPS is here and this is equals to, now if I am taking this triangle, angle SPO plus this triangle, angle SPT, so it is again 90 degree, this angle and this angle is 90 degree and this angle is this angle 90 degree. Okay, so can I have that some common angle P? This angle P is common in both the sides. So I can conclude from there that angle PTS is equals to angle SPO. Now SPO is this angle and TPS is this angle. So these two triangles are similar now. Okay. So by side angle side similarity, what I am having is triangle similar to which triangle? If I am taking this TPS, okay, TPS, so that will be PS is equals to PS, right? And we are having this angle T equals to P, so T equals to P, right? And the third thing is we are having PS common, PS. Okay, now we are having this angle S equals to S, so P equals to P and S equals to S, and then we are having this T equals to P. Okay, so that will be triangle PTS and SPO, that will be similar to each other. Okay students, so from there we can conclude. I will rub this thing. So their ratio will be similar. So now if I am taking this triangle T, S and P similar to triangle T, S, P equals to triangle OSP, then I can have TS ratio OS equals to SP ratio SP equals to TP and OP. Now I am having this this TS here, I am having with PO, right? So PO is here, so I will write 5 here, and then I am having 3 which is OS. Now OS is here which is 3. What I have got? This and this. This is 4. Now 4 is PS. Now PS is 4. PS is 4 here. Okay. So I can just simply eliminate this ratio. So this is equals to 1 TS and PT. Okay. So from there I can say that TS equals to 3 and PT equals to 5. Okay. Now what I have to find out? I have to find out TP. So this is equals to 5 centimeter. Note this students. Going to the next question. From a point P 10 centimeter away from the center of a circle, a tangent PT of length 8 centimeter is drawn. So I am having a circle. This is a circle. Okay. Now from the center of a circle, a point P 10 centimeters away. So I am having a 10 centimeter away point P from the center. A tangent PT, so P and tangent from this circle will be this. So that is T, is of length 8 centimeter. So this length is 8 centimeter given. Okay, is drawn. Find the radius of the circle. So you have to find this radius R. Okay, so let's suppose this is O. So now you can know that this is a right angle triangle because this is your radius and this is your tangent, students. So here is the solution part. Here is the solution part. you have some given information, that is you're having tangent, or I can say tangent equals to what? TP equals to 8 centimeters, and this PO, now PO is what? Distance between the outside point and the radius of circle. So, this is given 10 centimeter. Okay, this is the second parameter. Now, angle PTO, we'll take this in solution part. So, this was our given part. Now, the solution. So, I am having this angle PTO equals to what? 90 degree. Why it's 90 degree? Because this TO is perpendicular this PT. Why? Because TO is what? Your radius, and this is PT, which is tangent. So, tangent and PT, tangent and radius will be always perpendicular. So, it is 90 degree. So, in triangle PTO, what you will see, this is a 90 degree triangle. So, it what? This hypotenuse will be equals to, this hypotenuse square will be equals to square of this side plus square of this side. So, I can write R square plus 8 square will be equals to what? 10 square. What will it give me? 100 minus 64 equals to R square. Then R will be equals to root of 6 and 3. This implies that R will be equals to what? 6, isn't it? So, the radius will be what? Nothing but 6 in centimeters. So, R equals to 6 centimeters is your answer for this question. Alright, note it down so that we can move to the next part. Okay. Now, prove that in two concentric circles. Now, concentric circles are those circles whose center is same, okay, but radius is different. The chord of the larger circle which touches the smaller circle is bisect at the point of contact. You have to prove that you are having, okay, we have proven that in our previous session, we have proved that, okay. So, let us move to another. Prove that the parallelogram circumscribing a circle is a rhombus. Now, what is rhombus? What is a parallelogram? Okay. We have two things. Actually, we are having only one thing, which is a parallelogram. I am having this line. Now, I draw this line parallel to this line. Okay. Now, I draw a line bisecting it. Okay. Now, I will draw a line parallel to this line. So, these two lines are parallel and these two lines are parallel. Now, the closed figure, if I remove these lines, this closed figure, this closed quadrilateral in which I am having two pairs of parallel lines is known as parallelogram 1. And the second thing is, if these all four lines or sides, these four sides are equal to each other, that means if it's A, then it's A, then it's A, and this it's A, like we use to say this in square. But in square, the essential thing is the angle between the two sides, all the sides is 90 degree, but in this it's not compulsory. Okay. So, I have to prove that in a parallelogram, circumstance is a circle. So, if I am having a circle and I will draw tangents here, okay. So, this will be not a parallelogram, but specific case of parallelogram, that is rhombus. So, we will prove it in next session. Till then, keep watching. Thank you.